Hello everyone, in this tutorial we will create the obstacle avoiding system for our AI vehicle. Our AI vehicle will spawn the speed trace in the grid form and then get this information set to a star algorithm to find the best path to the target. And we spawn the new spline according to the path that we get from the algorithm. After that, the vehicle follow the new spline to avoid the obstacle. Open our last project, graphic tutorial. We need to convert this project to C++ project. So add new C++ class, character, next, choose public, and create class. And click OK, and click yes. We can close this and close the project. We need to add another plugin to the project. Create a new folder, name is plugins. I will put the link in the description so you can download this algorithm. So copy and paste it here inside this plugin folder. Delete.vs, derived data cache, intermediate save.vs.sln. We generate Visual Studio project files. Open this Visual Studio project. We can see inside this graphic tutorial, we have this new plugin algorithm. This is the blueprint library. And run this. We can open the project after we add this plugin. You can go to traffic, BP vehicle AI. Go to event graph and search for A star pathfinding. This is a new function from our blueprint library. We need to have the start point, goal point, grid width, grid height. If we enable this, we can choose the diagonal point for the path. And this is the return array of points. I recommend this article about introduction to A-star algorithm. Why do we use pathfinding algorithm? Because if we just compare the distance from one point to the goal point, we will get the path that look like the red line. We just choose the next point that is closest to the goal. So it moves straight to this location and they detect the obstacle cannot move forward and they move around this and then they get to the goal. But if we do some planning with the algorithm by comparing the cost of each path, they will get the better path to that goal. In this plugin is the blueprint library plugin that we can write C++ function and use this function inside blueprint actor. First, we create the struct f point it contains x and y value, which is the coordinate location of this point. We have some operation. This equal to check that if this point is equal to other point. Not equal to check if this point is different than other point. We have a star pathfinding function that we can call inside blueprint because this is blueprint callable function. And we return t-array of f point, which is the path point to the goal point. If the goal point cannot reach, this array will return empty array. Another struct is f node. It contains f point, g value, h value. This g value is the cost from start node, and this h value is heuristic cost to the goal. These two values we need to add together to check the cost of the point. And we have the parent f node to trace back from that f node to the start f node. We use this to reconstruct the path. We have the function, heuristic function. This used to calculate the cost, heuristic cost, and is valid. Check if that point is inside the grid. And get neighbor. This function used to get neighboring points of the current point. And reconstruct path when we need to create the array of points from the goal point to the start point. And inside this C++ file, we have the logic of this function. Go to Unreal Engine. Now we can move this vehicle here. We can delete this third person start point. Change this world setting game mode to this game mode. When we hit play, we don't spawn the third person, so it's easier for us to fly around. And we add the cube shape to create the obstacle. Set the scale to 5, 8, and 3. Move it up. Search for collision and choose generate overlap event. So when the line trace can detect it. Click on the floor and this collision. Make sure it don't generate overlap event. Let's play. Now our vehicle can detect the obstacle. It just ran into that obstacle. Click on this floor again and search for collision. And this collision preset. Choose custom and expand this. This visibility, set it to ignore, because when we do the speed race, we don't want to get this as the obstacle, this floor. Inside traffic folder, go to blueprint, enumeration. Name is E side. Open this. Add enumerator. The first is left and next is right. And save this. Go to blueprint vehicle AI. add a new function. This function name is line trace front obstacle. And input. The input name is side, and use the enum that we just create, e side. We will do the line trace by channel, and we need the start location and the end location. So we get actor location, add this, and break this vector. We want this location a little bit higher, so add this z value with 50 and make vector x to x, y to y, and z to z, and connect to start. We get actor right vector multiply this by float 80 and multiply this with float -1. Multiply by -1, we get the left vector. And this side or select. This one is the left, and without multiply by -1 is the right. And connect to add this actor location. This is the start location. Get control rotation. Break this rotator and use yaw to create vector. Set this pitch to 0. Multiply this. Get vehicle movement component. Get forward speed mph. Multiply with 60. Then add this with 800. Convert this to float and connect to this, and then add with this location. This is the add location of the line trace. We change this length of the line trace depending on the speed of the vehicle and connect to this. We can do the draw debug for one frame, and the hit break hit result. Add another variable is obstacle and change this to actor type. Set to array, get obstacles, and find this item, this hit actor. If it equal to -1, it means that this hit actor cannot found inside this obstacles array. So it means this is the new actor. Return and connect this. Return value. This is hit. Location. And this Boolean is new obstacle. Compile. Go to event graph. Create a new custom event. Name is an map obstacle. And then add another function. Update obstacle detection. Call the line trace that we just create. This left and promote these two variable is hit location L and copy this line trace, right, promote this, hit location O and this hit or Boolean, create a branch. If it's true, we add another variable, avoiding obstacle. Change this to Boolean and single. Get this, create a branch. If the vehicle is not avoiding obstacle, we call analyze and map obstacles. So we do the line trace for left and the right and set this hit location. And if it hit and the vehicle is not avoiding the obstacle, we call this analyze map obstacle. We can add pin. And this first one called update obstacle detection. Print string this. In string is detect. And we can set this to file. Compile. Play. And now we detect the obstacle with the line trace. We can disable the debug of this break. Disable this. Delete this print string. Add function. Name is get nearest line point to hit. Name this input is target and this is Spline BP Spline road object reference location L vector location O get Spline Call find location closest to world location, and coordinate space is world, and we get location L, get location R. Add this location together and divide, convert to float, and select float. Copy this location. Vector is 0. And call all boolean. This vector is 0. If the line trace didn't hit, we get the 0 vector. Connect to this and set to 1 and 2. If it's true, it is 1, and if it false, it is 2. And connect to world location. Call return. Connect to this return node. This output name is closest location. To event graph, add another function is pair trace grid. Inside this pair trace grid function, we need other function get grid center location. And this is the pure function. Add variable grid height, integer. Another variable is grid width, integer. Duplicate this variable. Control D is grid gap. We can set this category to grid control. And this grid width to grid control, grid gap to grid control. By using this variable, we can control the size of this grid. Compile first. We can set this grid height to 16, grid width to 16, and this gap to 200. Let's get grid height, add with 1, multiply with grid gap, and divide this by -2. Copy and grid width. Get actor rotation. Click this. Make a rotator. We use only the yaw rotation because we don't want the pitch of the vehicle and the roll affect this direction of the grid that spawn. Get forward vector. Get right vector. Multiply this. The forward we convert to float or convert this to integer. connect this and multiply, convert to integer, multiply, add variable grid center location vector, get this grid center location, add with this location, call return, connect to this, and this is the return value. We do this to get the center location that we should spawn that grid. Add function. This function name is draw debug sphere with point. Add input point, and this type is point. Radius float and line color. Linear color. We call draw debug sphere. First, we need to get the center location. Get grid center location function. Add this point. We break point. Add with 1. Multiply with grid gap. And this y. Add with 1. Multiply with grid gap. Make vector x and y. Move here. Get actor location. Split this. This z we subtract with 20. Next to z. Get actor rotation. Make rotator. Use this yaw to make rotator. Need to yaw and rotate vector. The vector we use this vector from the point and add it with grid center location next to this center, and connect this radius to radius, line color to line color. Set the duration to 4 and the thickness is 1. Close this. Now we can go back to spear trace grid. Add input grid center location and vector, promote to variable. This is grid center location. We get obstacle array and clear this array. Add another variable is obstacle location grid and change this to array. Clear this first. Get grid center location function. Add new local variable is column location single and row location high index integer and width index integer. Then we set this column location. Call for loop. First index is 0 and the last index is grid height minus by 1. We minus by 1 because this start from 0. So our grid height have 16. Start from 0, it is 15. And we set to high index. Get column location. Add. Get actor rotation. Flip. Make rotator. Next yaw to yaw. Get forward vector. Multiply this with the integer. Grid gap. And connect to add. Then set this to column location. Next, we get this column location and set to row location. To continue the loop, copy this for loop and connect to this. Get grid width, subtract with 1 to the last index and set to width index. Get row location, add this. This one we get right vector, copy this, multiply with grid gap, multiply with right vector and connect to this. Can move this back here and set to row location. After that, we can call sphere trace by channel. And we get this row location. Start and add location, the same location. And we get grid gap used as the radius. We don't need to debug this. And we can add to the array this obstacle location grid. Add array row location. Get obstacles and add unique. For the obstacle that this speed trace overlap, we add to this obstacle array. And add another variable is grid array get grid or set array element. This hit set to item get high index multiply with grid width. And add with index set to this index. And we size to fit to scale this array. Add another variable, name is debug grid. Variable type is boolean, chain to single. Choose category is debug control. Compile and set it to true. Get debug grid, create branch, and we get this hit result to change the color of the debug sphere. Draw debug sphere with point true and when it's false. And this point we make point high index and width index use as the point and set the radius to 25. The color, this one to yellow, red to 1, green to 1. And this one, green to 1, blue to 1, light blue. And after we complete this function, we return get obstacle location grid and this grid. So in this function, we just find the location that we need to spawn this spear trace. And for the result, we add it to the array. This obstacle location grid and this grid index. And then we do the debug. Go to event graph, call do one, add this variable, mapping obstacle boolean, set this to true, get min speed, and set this to max speed, multiply by 2, because we want to slow down when it detects the obstacle. Get vehicle movement component, set handbrake, set this to true. We want to stop the vehicle. Get Spline actor, get nearest Spline point to hit, make this to target, hit location L, and hit location O. And call spear trace grid. Can compile and save. We made a little bit of mistake inside this spear trace. We create a new grid center location. Use the last one. Delete this. Compile and delete this. Let's play. Now we spawn the spear trace in the grid form to trace the obstacle. Again, the blue one is not aligned with the obstacle and the yellow one is aligned with the obstacle. To debug further, we can add another function. Name is debug map array. Input is location array and integer grid. For the location, we call for each loop and call draw debug sphere. With the radius is 25. The color not yet choose. Duration 20. Thickness is 1. And we select color. If it's true, we set it to red. And if it false, we set this to green. We get the grid index, this array index, and connect to pick. And we want to debug the index of this array. So go to plugin and search for text 3D text. Enable this text 3D generator and restart now. We can close this plugin and we create a blueprint. Search for 3D text, this text 3D actor, select. Name this to BP underscore debug text. Click on text 3D component. Set this horizontal align to center to place it in the center location. Go to event graph. Create another custom event. Rename to set text. Get text 3D component or set text. Add input text and variable type is text. Connect to text. Compile. Save. We can go to BPV Core AI and close this blueprint. Spawn actor from class. Choose BP debug text. Click this spawn transform. This array element. Break. Make vector x to x, y, and z. We add it by 100 to lift it up from the floor. Connect to location. Rotation y is minus 90. And we call that text. Connect array index to this text. Compile, go to event graph. We call debug map array and use this location grid and this grid array. Save. Let's play. We can set this to 10. The value. Let's play. And now we can see the index from 0 to this 15. The add of this index is 255. So this is really useful for you when you want to debug this array. You know the order of the index. We can disconnect this debug. Add new function. Find nearest location. Input array. Vector array. And location. Single. For each loop of this array, we get the distance from this array element to the location that we want to compare. If the index of this array is 0, we create a branch. This means that this is the first index. We add another variable, name is distance. Float and set to this distance. And add another variable is nearest index. And set to integer. Set this array index. Next, we compare if less than distance and create a branch. Copy this. If it's true, we set this distance and this array index. This means that the first index of this array location, we automatically set this to the nearest index because we don't have anything to compare. After that first index, we need to compare. If the distance is less than the distance, we set to the new nearest index. And then return get nearest index next to this return. Name this to start index and get array. Get a copy of the nearest index, and this is the start location. We can call draw debug. Copy this draw debug sphere. Connect this and use this location and change this color to dark blue. Compile. Let's go to event graph. Call find nearest location. And this obstacle location grid. And we get actor location. So this is the start location of the pathfinding. Add variable is start index. Another variable is start location. Set to vector. So to review about our algorithm, we can find a star finding, the start location, start point. Now we have the start point from the nearest array point that near to the actor location. We not yet have the goal. This is our next function. We find this goal, and we have this grid array, grid width. we already set it in grid high, and we use octal heuristic, so we can use the diagonal path. Add another function, name is find base target location. Inputs grid integer array. Spline BP line route. Object reference start location. Set to vector. We can just add local variable base location index integer base location distance target to spline float distance start to target score and base score. So in this function, to find the base target location, we need to compare the score, which is the base one. By compare the distance target to spline, we want that location nearest to the spline, and start to target distance, we want that location is far from the start location. So first we set the score to 0 and the grid call for each loop, and array element equal to 0, create a branch. If that array element equal to 0, this means that that point isn't overlap with obstacle. If it equal to 1, it means it's overlap. And it's spline, get spline, find location closest to world location, and change this coordinate to world. Get obstacle location grid, get a copy from this index and connect to world location. Find the distance from this to this array location, and we set this to distance target to spline. Get start location and find the distance from this location to this array, and set this to distance start to target, and we calculate it, and then we calculate the score. Get target to spline and get start to target. This start target, we want it to be far location, and we subtract with this target to spline, because this target to spline we want it to be nearer to the location, and set to score. We compare with the base score. So the first base score is 0. We create a branch. Get score and set base score. You don't need to set base score to 0 here because this is the local variable. So when we call this function, every time this local variable will set to the default value is 0. And set base location. This is the array location. And set to base location index for this index. For return, this start location, we can use this location. Get base location index to return base location vector. This is target index and target location. Compile, go to event, call find base target location, get grid, get spline actor, get start location, and add variable target index integer target location vector. Set this. And now we have the goal point. We can create a new custom event. Name is generate at spline. And after this target, we call this generate at spline. You can copy this draw debug sphere to debug this target. Compile and save. Let's play. And we can see here is the target location. You can set this debug radius to 30 and another one, this one to 30. So it's visible for us. Let's play. And you can see this is the target location. We can add another function is grid index to point. We want to convert the grid index to point. So add input is grid index set to integer. We divide this by grid width. Get grid width, and this modular with grid width. Make points. Next to x and y. And call return. Next to this return. And set to pure function. To event graph, we can add another variable name is at location. And this is the array. First, we clear this array first. And connect to a star pathfinding. Get start index. Get target index. Call the new function grid index to point. Next to start. And the other one is next to goal. We get the grid array that we initialize in this function via trace grid. In grid control category, we have grid width and grid height. And we return the array points. Call for each loop. Debug control. Debug grid. Create a branch. Draw debug sphere with point. And change this line color to pink color. This blue to 1. And if it's true, we debug with this point from the array element. And the radius is 30. And we add this at location. Next, when it's false to add another function, grid point to location. Set this to pure function. Add input is point. Array type. Variable type is point. Break this point. Add with 1. Multiply. Find grid gap. And multiply with this grid gap. Make vector to x, y, get actor location, split in Z, get actor rotation, break rotator, make rotator, yaw to yaw, call rotate vector. Connect this vector to this rotate vector and get grid center location function. Add with this vector and we return. And close this. Go to event graph and can use this grid point to location. Use this point and connect to this location. Compile and save. Let's play. Now we can see the path to the target. For this draw debug, let's set the duration to longer duration, set it to 20. Next, we will spawn a new spline for this path location. Add function called spawn new spline. Spawn actor from class BP spline road. Then we get grid center location. Split this. Get spline component. Call set draw debug. We want to show this spline. Add another variable. Name is debug new spline. Boolean single. Set category to debug control. Compile. Set to true. And connect to show. This spline with clear spline points. Get path location. Call for each loop. For this spline, add spline point. Add to this location and where coordinate space. When we complete, set spline actor and set to this new spline actor that we spawn. And then set avoiding obstacle to true. And we stop the mapping obstacle to false. And go to event graph. In this analyze and map obstacle event, create a new custom event. Name is reset, analyze, and map. Connect to reset. Go back to this function and call this reset, analyze and map. When we reset, we can call this event again. We can go to this generate at spline after we complete, call spawn new spline, compile, play. Now we have this spline that go from start location to the target location, but our vehicle still have the handbrake. Because when we call analyze and map obstacle event, we set this handbrake to true. So we need to disable this. And this event tick, move this here, create a sequence, and disconnect this. Get mapping obstacle, create a branch. If it falls, and create this sequence. We call update after this. Get avoiding obstacle, create a branch. If this true, we call movement component, get forward with mph less than, get min speed multiplied by 3 and connect to this. If this true, get vehicle movement component, set handbrake to false. So we disable this handbrake after the vehicle is stopping. So we disable this handbrake after we set this avoiding obstacle to true. We set this avoiding obstacle to true after we found this new spline. And we can collapse this as function, rename to check target arrival. Open this. And we create a sequence. Create a branch. Get actor location. Distance to the target location. And less than 2 grid gap distance. If this true, this means that vehicle already arrived at the target location. So we need to reset the default spline back to the main spline that loop around. Create another function. Name this reset default spline. Get spline actor. Check if it's not equal to default spline. This means that this is the new spawn spline that we create to avoid the obstacle. Create a branch. If this true, we destroy that new spline. Destroy this spline actor. And we get default spline. Set back to spline actor. And set avoiding obstacle to false. Get default max speed and set this vehicle max speed back for the vehicle to drive faster after they don't have any obstacle. Go to check target arrival. After we arrive at this target, we call reset default spline. Sorry that I connect to this wrong. You can connect to this target speed. And this line trace, we stop debug this. Set to none. Let's play test. Now the vehicle can follow this new spawn spline. And it's know when it's arrived at the target. Duplicate this obstacle. Open BP vehicle AI. We close all these functions. In update obstacle detection, for the new obstacle, call or boolean. If we detect the new obstacle, create the branch. If we detect the new obstacle, we analyze and map obstacles. Before we analyze the obstacle, we need to reset the spline and connect to analyze and map obstacles. We do this because when we detect the new obstacle, we don't need the vehicle to arrive at the target location. We just do the analyze and map the obstacle immediately. Add bug collision. Name this to bug collision. Set bug extent to 310, 150, and 50. Location -20, X, Z is 80, and we can search for collision, overlap, or dynamic. Go to event graph and scroll down on component begin overlap. Add this event. If other actor not equal to safe, if it's true, call do one and call reset default spline. Call analyze and map obstacle. Then delay for 2 seconds and reset this back. If the vehicle get near to the obstacle, this bug will overlap with the obstacle. And if it overlap, we need to reanalyze the position of the obstacle and find the new spline to avoid that obstacle. And we delay for 2 seconds to reset because we don't want the overlap to call this event multiple times. And go to this analyze and map obstacle event. Add input. Name is actor grid center. If we call this analyze and map obstacle from this collision, we set this actor grid center because we don't have the line hit overlap location. Get actor location. Add this with get actor forward vector multiply get grid height subtract with 1 divide by 2 and multiply by grid gap. And connect to this and connect to this actor location. We can collapse nodes, rename to actor base grid location. Open this, and this is the return value. Call select vector If this actor grid center is true, we use this actor base grid location as the grid center location. And if it falls, we get this closest location as the grid center location that we get from the line trace. File and save. I added a few obstacles for this vehicle. Go to draw debug sphere with point and reset this duration. Let's set it to 3. And this target location, we disconnect this draw debug sphere. And this find nearest location, disconnect this draw debug sphere. Can close all these functions. Let's play. Now the vehicle can detect the new obstacle. And if it's overlap with the obstacle, they will spawn the new path. We can duplicate this and create a wall. What's happened when the obstacle blocks the path and the vehicle can't reach the target? You can see that we still have the problem because the vehicle continues to move forward. To solve this, we can go to this generate path line and add new variable is stop. If this point is empty, we set stop. Go to this event tick, get stop, create a branch. If this variable is true, we need to stop the vehicle. So create a new function. Name is stop vehicle. Get vehicle movement component. Get forward speed mph. If this less or equal to 0, create a branch. If this true, we get vehicle movement component. Set brake input to 0. Set throttle input to 0. And if this falls, we set brake to 1 and throttle to -1. To event graph, if this true, we stop vehicle. and delay for 5 seconds. Reset default spline and call analyze and map obstacle. Enter grid center is true. We stop the vehicle and we delay for 5 seconds, and then we analyze the obstacle again. Let's set this obstacle to movable so we can move it in runtime. Let's play test. Now the vehicle can find the target, can reach the target, so it stops and it's do the analyze the obstacle every 5 seconds. Let's move this obstacle. Now our vehicle can find the path. Go to BP vehicle AI. We need to organize some of the variable. This obstacle. Let's set a new category is obstacle. Hit location L to obstacle. Hit location O. Avoiding obstacle. Grid center location. Obstacle location grid. Grid array. Mapping obstacle. Start index. Start location. Target index. Target location. Add location and stop. Let's move this down. And for this speed control, we can set this to public. This debug. Grid height, grid width, and grid gap. This category that have the control name, you can adjust this variable. If you think that this grid height and grid width 16 is not enough, you can increase this value. This system still have some problem because our vehicle can get stuck. Sometimes the vehicle can turn to move to the line that need to avoid the obstacle. So we need to improve this in the next tutorial. And in the next tutorial, we will make this system more adaptive to the dynamic obstacle. This is the end of our tutorial. If you like this tutorial, please hit like and please subscribe to my YouTube channel. Thank you very much for my patrons member who are supporting me. Your support really means a lot to me. See you in the next tutorial.